Hi, this is the Science Chef. As promised in our last tutorial, today we'll be looking at the second part of a series on projectile motion, which we title Vertical Projectile Motion. In this video, we will learn more about vertical projection with some examples on how to solve problems on vertical projectile motion. If you want to know everything about vertical projection, endeavor to watch the video to the end. In our last tutorial on definition of projectile motion, we learned that the body undergoes vertical projection when thrown vertically upwards into the air. It falls back freely to the ground under the influence of gravity. If you'd like to watch that video, check the link in the description. Vertical projectile motion is also known as free fall motion. Examples of bodies that undergo free fall motion are those objects thrown up into the air and allowed to fall freely downward, like a stone, ball, bullet, etc. When the body is thrown upwards, it leaves with its maximum initial velocity, and as it goes upwards, it moves against the force of gravity g, so its acceleration decreases steadily at a rate of about 10 meters per second squared until it gets to its maximum height H, where its final velocity becomes 0. At this point, its motion reverses and it starts coming down. Its initial velocity for the downward motion is the same as the final velocity for the upward motion, which is 0. Conversely, as the body comes down, its acceleration will increase at a steady rate of about 10 meters per second squared because its motion is in the same direction as gravity until it hits the ground with a maximum velocity, which is the same as that with which it was launched into the air. In studying vertical projectile motion, we will be applying the basic equations of motion, especially those that have to do with acceleration as displayed on the screen, where u is the initial velocity in meters per second, v is the final velocity in meters per second, t is the time taken in seconds to cover a given distance, s is the distance covered in meters, while a is acceleration in meters per second squared. Starting with the upward motion, let's now analyze the two different parts of the vertical projection using the equations of motion. In the upward motion, the initial velocity u of the body will be equal to uy, while its final velocity v at the maximum height will be equal to 0. Since it goes upwards, it undergoes a retardation or deceleration, that is, a decrease in acceleration, because it is moving in an opposite direction to the force of gravity. So its acceleration a will be equal to negative g, and the time it will take to reach its maximum height will be t. Remember, its maximum height H is equivalent to the distance s covered in the upward motion. Therefore, substituting these values into the three equations of motion, they will become Vy equals to Uy minus Gt, H equals to Uyt minus half Gt squared, and Vy squared equals to Uy squared minus 2Gh. Since the final velocity of the body is 0 at the highest height, then from equation 4, we would obtain Uy equals to Gt. Equation 7 gives the initial velocity for the upward motion in terms of acceleration due to gravity in meters per second squared and time in seconds. Similarly, from equation 6, we would obtain Uy equals to root 2Gh. Equation 8 gives the initial velocity of the upward motion in terms of acceleration due to gravity in meters per second squared and the maximum height attained in meters. From equation 6, we will obtain H equals to 2y squared over 2g. Equation 9 gives the maximum height in terms of initial velocity in meters per second and acceleration due to gravity in meters per second squared. And lastly, from equation 7, we can obtain t equals to uy over g. And equation 10 gives the time for the upward motion in terms of initial velocity in meters per second and acceleration due to gravity in meters per second squared. In the downward motion, the initial velocity uy of the body is 0, while its final velocity with which it hits the ground is vy. Since it falls downwards, its acceleration a will be equal to positive g, and the time it takes to fall from its maximum height h to the ground remains as t. Therefore, substituting these values into the three equations of motion, we will obtain Vy equals to gt. Equation 14 gives the final velocity for the downward motion in terms of acceleration due to gravity in meters per second squared and time in seconds. Vy equals to root 2gh. Equation 15 gives the final velocity of the downward motion in terms of acceleration due to gravity in meters per second squared and the maximum height attained in meters. Capital H equals to Vy squared over 2g. Equation 16 gives the maximum height attained in terms of the final velocity in meters per second and acceleration due to gravity in meters per second squared. Similarly, from equation 12, capital H equals to half gt squared. Equation 17 gives the maximum height attained in terms of the acceleration due to gravity in meters per second squared and time in seconds. And lastly, t equals to Vy over g. Equation 18 gives the time for the downward motion in terms of the final velocity in meters per second and acceleration due to gravity in meters per second squared. If we add the time for the upward motion to that for the downward motion, it will give us 2uy over g. This is because the initial velocity for the upward motion equals the final velocity for the downward motion. This gives us the time of flight, capital T. The time of flight is defined as the time it will take the body to reach the maximum height and return to the ground. Let's now see how to apply these formulae by solving some examples. Example 1. A tennis ball is thrown vertically upwards from the ground with a velocity of 40 meters per second. Calculate 1. The maximum height reached, 2. The time to reach the maximum height, 3. The time of flight. To solve this problem, let's extract the given parameters. From the information provided, we are only given the initial velocity uy of the tennis ball, which is 40 meters per second, and asked to calculate the maximum height, capital H. Since it was thrown vertically upwards, it means it underwent a vertical projection. Recall that at the maximum height of the upward motion, the final velocity Vy of the ball will be equal to 0. And the acceleration due to gravity is 10 meters per second squared. So the next thing is to get the formula that connects u, v, g and h for the upward motion, which is Vy squared equals to uy squared minus 2gh. Substituting the values of the parameters and solving for h, we will obtain 80 meters as the maximum height reached by the tennis ball as shown. To calculate the time taken to reach the maximum height, we can either use the equation that connects u, g, h and t, since we know the values of all the parameters except t, or we can use the equation that connects v, u, g and t for the upward motion. For convenience, let's apply the latter, which is Vy equals to uy minus gt. Substituting the values of the parameters and solving for t, we'll obtain 4 seconds as the time taken by the tennis ball to reach the maximum height as shown. To calculate the time of flight, we will just multiply the time taken to reach the maximum height by 2, since it is the total time it will take the tennis ball to get to that height and return to the ground. So that will give us 4 seconds times 2, which equals 8 seconds. It's now your turn. Example 2. A ball is thrown vertically upwards with a velocity of 15.5 meters per second. 1. What is the retardation of the ball? 2. What distance does it travel before it comes to rest momentarily at the top of its motion? 3. find the speed of the ball just before hitting the ground. Just like the first example, we will extract the parameters from the question. From the information provided, the initial velocity of the ball is 15.5 meters per second. Being a vertical projection, its final velocity Vy for the upward motion will be 0, and the acceleration due to gravity is 10 meters per second squared. The retardation of the ball is 10 meters per second squared since it is negative acceleration. It is a negative acceleration because the upward motion of the ball is in an opposite direction to the force of gravity. As explained earlier, this is why the velocity of the ball will keep reducing at a steady rate of 10 meters per second until it gets to its maximum height, where its velocity becomes 0. The distance traveled before it comes to rest momentarily at the top of its motion is the same as the maximum height attained. Since we know the values of u, v, and g, we will make use of the equation that connects the three parameters to h for the upward motion, which is vy squared equals to uy squared minus 2gh. Substituting the values and solving for h, we will obtain 12.01 meters as shown. The speed of the ball just before hitting the ground is the final velocity for the downward motion, which is equal to the initial velocity for the upward motion, which is 15.5 meters per second. Alternatively, you can solve it by using the equation connecting u, v, g, and h for the downward motion, which is vy squared equals to uy squared plus 2gh. Bearing in mind that the initial velocity at the maximum height for the downward motion is 0. Substitute the calculated value of h and the value of g and find the square root of both sides to obtain 15.5 meters per second. If you are able to learn anything from this video, kindly drop a comment, give us a like, share this video and subscribe to our channel to encourage us to do more videos like this. Remember, winners never quit and quitters never win. So keep fighting till I see you when I'll see you.